bridge that gap, bridge that discrepancy, and set up an institute that solely caters to data science education, so that as people who are coming out of universities, or people who are looking to switch their careers in, can facilitate themselves by uh, getting a quality data science education through our platform, and be able to facilitate the industry growth in Pakistan. So really, our mission is to become Pakistan's premier data science institute, and we wish to bridge this gap that has existed between academia and industry by providing the skill-based education. Moving on, so here's a brief slide of what we've achieved so far in terms of our accomplishments over the last year. So FDI has been in operation for a little over a year now, and we are proud to say that we have been successfully able to graduate 5 cohorts, both online and in on-site capacity for data science, and we are currently running in parallel one additional cohort for business intelligence online. We're proud to say that we have trained over 100 students in through our quality data science platform, and we have been successfully able, and those students have successfully been able to finish 12 capstone projects. So I will brief you a little bit about what capstone projects really are. It's also one of the most interesting modules of our certification, so just bear with me. And while doing so, we've also successfully able to train employees of up to of about 10 corporations in Pakistan. So we're quite proud of our numbers that we've achieved over the last year or so. Moving on, so this is our teaching faculty, and pretty much all of our instructors have very sound background in analytics, either in working capacity or in academics capacity. Starting off with Abrar, he will be your instructor for the first module, the Python module, and I would like him to give his introduction a little later in the presentation. But just to briefly touch upon, he has about 6+ years of experience, industry experience, working in the field of analytics from the perspective of strategy and business development. And he has a bachelor's in business administration and a master's in business administration from IBA. Moving on, our machine learning instructor, Sania, she has been working in the industry for a little over 2 years now, and she will be taking over. She will be teaching you the supervised and the unsupervised learning modules, and she has a degree from NAD University. Next up is Usman Ali. So he will be your instructor for the forecasting module. That's the module that will come towards the end of this certification, the 5th module, where more on that module a little later in the presentation. So he has about 10+ years of experience in teaching, and he recently joined the industry, and he has been able to gain about 2 years of experience in working in analytics as well. So he's currently pursuing his PhD from IBA in machine learning, and he has an MS in computer science and a bachelor's in computer science as well. And last but not the least, Ayman Rehan, she is our program manager. She's also one of our full-time data scientists. And she also used to be a teaching assistant in our faculty. Now she teaches one of the modules, and she also supports all the instructors by taking care of the practical sessions that we aim to host regularly during the course of your certification. She will also be joining us a little later in the presentation. Right now she has a class going on, but yeah, she'll be joining us a little later in the presentation for her introduction. Sure. Moving on, the board of directors. So starting off from myself. So my name is Konain Qurban, and I'm the founder of FDI. And I have about 6 years of experience working in the field of analytics in New York. and I have a master's in applied maths and a bachelor's as well. And moving on, Qurban, she is our managing director. She looks after our, um, she's one of our subject matter experts when it comes to um, updating the course curriculum for our data science certification. And she's also one of the brains behind the capstone projects that we do on an ongoing basis. So she provides a good support mechanism for all our students who partake in the capstone project. She is currently leading the AI and analytics practice at Deloitte in England, and she has an MS in applied statistics from Oxford University, and she also has a bachelor's in statistics from UCL in London. Finally, our director, Adam, he's also one of our organization's mentors and advisors, and he's one of the reasons why we have been successfully able to carry out the vision of FTI over the last 1.5 years. He also boasts significant experience in quantitative field, in analytics field for over 25 years, and he currently works in New York, and he looks after FTI from there, and he provides his guidance, his advisory support um, in our course, in our projects, and also in training our instructors. He has a bachelor's from Harvard University and an MA from Columbia University. Moving on to our advisors. So basically the point of sharing this slide is that when we started FTI, we really wanted to have a set of individuals who can really help us to connect with the industry and be able to really understand what kind of problems do the industries in Pakistan face, so that we can adequately and accurately curate a course that will train the students so that once they get into the job market, they're able to facilitate the industry and solve their issues. So we're very lucky to have some of the finest advisors on board, starting off from Dr. Zaki. He's a healthcare professional, and he's been a big advocate of analytics from the healthcare perspective. He has about 20 plus years of experience working in this field, and he has been a constant source of inspiration and a constant source of introductions for FTI for over a year now. Moving on, Chaudhry Saab, he's one of our main advisors when it comes to our course, when it comes to getting introductions in different industries. And also, he's one of the key people when it comes to advising our students, because what happens is that oftentimes our students are struggling with finding the direction in terms of what can they do once they finish this course, or what are the different possibilities that are out there in Pakistan for them. So Chaudhry Saab has been a constant support in terms of that, and he's a very humble and down to earth person, and he's very approachable, and he's always there to help our students out when it comes to giving them advice and doing knowledge sharing in terms of ideas. So he's currently the head of data science at Systems Limited, which is one of Pakistan's biggest software houses. Previously, he served as the head of data science and digital banking at Bank Al Falah, and he has a bachelor's in computer science from FAST University in Pakistan. Finally, we have Sana. She looks after our public relations efforts. So we do get reached out by the industry oftentimes, either in training capacity or in some sort of problem solving or project capacity. So she really helps us to manage those communications for us, and she really helps us to be able to present our best versions to the industries that are reaching out. And yeah, so that's Sana, and she has worked in various different capacities in the past, both for local organizations as well as multinationals. All right. So before I move on to the modules part, I would like to ask if anybody has any questions that they would like to share or anything that they would like to discuss so far. Okay, I guess we can move further. So, all right, so moving on to the modules part. So I would like, okay, no problem, Ahmed. All right, so I would like Abrar to, tell you a little bit, in more detail about each one of the modules that we'll be covering. However, I'll just give you a brief overview of each one of the modules, um, just so that you guys have an idea of what to expect as we go along. Starting off from the first module, where we aim to develop the foundations of data science and analytics for each one of you guys, and we strongly believe that knowing Python programming and knowing SQL forms the essence of any data scientist anywhere in the world. So if anybody comes up to you and says, okay, oh, you can be a data scientist without knowing programming, chances are that that statement might not be true. Because once you go and work for either a project in the industry or a data analyst or data scientist role in the industry, you will be interviewed on your programming skills, and you will be asked to, or you will be expected to know programming. So we really, take you through in profound detail with programming, whether you know programming or not. So we have a very strong focus on Python and SQL, and that will be your first module. So your first module will really lay the foundation of all your future data science modules. So your second module will be exploratory data analysis, where we will be touching upon how to prepare the data once you have access to the data. Because oftentimes what happens is that this forms the first step in your analytics process. And that is that once you get the data, you're expected to ensure that there are no data quality issues, that the data governance is flowing as per the requirements of the corporation, that there are no outliers, and that statistically the data makes sense. So the techniques that are being used in EDA, we will be covering each one of them in profound detail as we go along this module. And this will be your second module. So moving on, the third module will be supervised learning, which is also called machine learning 1. And here in this module, you guys will be covering all the classification machine learning techniques and also regression techniques. So in this module, you will be introduced to the actual predictive analytics part of your data science life cycle with us. And this will also form as one of the core you can say learning objectives for your certification, to know the machine learning algorithms. Moving on, the fourth module will be unsupervised learning, where we will be touching upon the clustering techniques. And here, this is also form of machine learning. And here, you will be learning all the different unsupervised learning algorithms in detail. And moving on, the final module of your certification will be time series forecasting. Here, in this module, you will be learning prediction with respect to time. So oftentimes you see, like organizations trying to predict their sales, or stock market trying to predict, when or how this particular company is going to do in the future. So all these predictions are done with respect to time. And so there are certain algorithms which are called forecasting algorithms. So we will be covering in detail each one of those algorithms in this final module of yours. Finally, the most important aspect of your certification with us will be the capstone project. So the point of the capstone project, as I was mentioning earlier, is that to ensure that your learning with us over your past 5 months has been thorough, and that you truly understand each one of the concepts that we have covered in the certification, through the certification. So what will happen in capstone projects is that either you guys will give us some ideas, or we will provide you with some data science project ideas, and we will form teams for each one of you. And then you will be asked to apply each one of the techniques, each one of the steps of that you've learned in your data science certification in that project. And eventually you will be asked to prepare a report and present that report to our to our board. And that will really help us ensure that your data science learning has been validated, and it will also enable you to know that everything that you learned over the past 5 months with us is well and truly complete. So when you go into the industry, you are actually taking a material experience with you, and also you have this capstone project to show to them that how to apply these various different data science techniques. So really, our certification is very comprehensive, and it's complete. And we feel that everything that we do in this certification is hello. Yeah. So we feel that everything that we do in this certification um, is serving a purpose. So that's why our certification is slightly longer than you would expect. It's 5 months, but we ensure that we cover each and every aspect of your data science learning. Okay, so moving on, some housekeeping rules. So each lecture, so we'll be having the classes every Saturday and Sunday. So today's class is from 7 p.m. to 10 p.m. However, at the end of my presentation, we're going to be doing a poll, and you guys can let us know collectively what you think should be the time for this class. So the class time will be 3 hours every day, only Saturday and Sunday. And you will be expected to log in 5 minutes before the start so that we can promptly start on time. There will be a designated instructor for each module, and you will also be provided with a teaching assistant who will act as the communication bridge between the instructor and you guys. So the teaching assistant will aim to facilitate you guys with any question that you have um, with respect to the lecture that you went through, and any question that you may have regarding the homeworks that you get assigned, the quizzes that you get assigned, or just anything in general, related to our certification. There will be a break in between lectures for 10 to 15 minutes, and that will be at the disposal of the instructor. So the instructor will announce the break during the lecture in the middle. And there will be, so all the lectures will be live and online each week, and we will be sharing the recording for each lecture on your Google Classroom, so you can review the recording in case you miss out on any lecture, or in case you just want to review what we covered in the previous week. Yeah, so we also have a protocol for our Zoom classes. So we have felt over our previous cohorts that students just abruptly open their mic and start asking questions while the instructor is delivering a lecture, which is kind of um, not pleasant, because it breaks the flow of the lecture and it really puts the instructor off. So I think the best to overcome that issue, so we really would like, if you guys have any questions, if you can raise your hands on Zoom, and then the instructor will acknowledge that you've raised your hand, and then he will ask you to, or she will ask you to unmute your mic and then ask your question, or speak, or say the answer to any question that the instructor has asked. The purpose is to keep the Zoom sessions as lively and as engaging as possible. So we ask all of you guys, as you're entering the lecture, to mute your mics. And finally, the course outline. And so somebody did ask in the group earlier, The course outline, the syllabus for your entire certification, and the student policy document has all been shared with you on your Google Classroom. So we expect you to review it um, before tomorrow's class so that you guys are all aware of the proceedings. Finally, well, not finally, moving on. So our objective at FTI is to really exceed your expectations. And therefore, in order to curate the best possible data science learning experience for you guys, we have put together this cohort engagement form. Now, the purpose of cohort engagement form is that we would like to ask you guys to let us know exactly what your motivations are to study this course and what do you expect to get out of it, and exactly what kinds of data sets, what kinds of projects, what kinds of um, algorithms do you plan or hope to work with or on. So the code engagement form will be shared with you at the end of this lecture on WhatsApp. And you can, the last date to submit your cohort engagement form is Tuesday. So we'd really like if you guys can take some time and really thoroughly fill that document and share it with us, because it will really help us to, you know, provide you the best possible experience of data science learning. And as because also we know exactly what your expectations are, and we know what to meet and what where to exceed. So we'd really appreciate if you can you know look at this form as well, which will be shared with you at the end of this class. Okay, so I think Abrar has already shared the cohort engagement form, so you guys can take a look at it at your convenience after this class. And if you have any
I haven't.
questions,
Sorry, it wasn't the cohort engagement form. There's Miss Fabiha who wanted to join the class, so I just highlighted the Zoom link
okay,
there.
okay,
Yeah, yeah.
no issues.
We can share the
So
engagement form later, not an issue.
later on.
Okay? Sure, sure.
Thank you.
No.
All right, moving on. So these are some of our communication portals. So starting off, so we have a WhatsApp group, and so the purpose of sharing this slide with you is that we have dedicated communication channels for dedicated inquiries from you guys. So and this really helps us to manage the communication with you guys and also ensure that each one of your queries get addressed in a timely manner. So your WhatsApp group that has already been created and you guys have already been added to it, it is going to act as your virtual notice board and a discussion group. So any announcements, be it events, be it job related, be it anything else that's coming from us, it will be shared on your WhatsApp group, and you guys can also use this platform to discuss anything related to your course, anything related to the lecture, anything related to an idea or your projects. So this is going to be your virtual discussion group and your notice board, the WhatsApp group. Then we also have a Google Classroom, in which I hope by now all of you have joined, because the code has already been shared with you. So the Google Classroom will act as your document repository. So all your lecture recordings, all your syllabus, course outlines, student policy documents, all your homeworks, assignments, final exams, um, quizzes, capstone projects, information, everything will be shared on the Google Classroom. Nothing will be emailed to you, nothing will be WhatsApp to you. Everything will be put on Google Classroom, and you will be expected to review those your Google Classroom on a regular basis, because you'll also be expected to submit or turn in your submissions on Google Classroom. So you're not expected to email us your submissions or WhatsApp us your submissions. Everything is going to be done through Google Classroom. So Google Classroom is basically your document repository and also a mechanism to turn in your assignments and quizzes and exams. Finally, just some social bit of information, just so that we can stay in touch, because FTI is a growing organization and we are providing training, but we also are venturing into advisory space. So we do have, you know, openings, job openings, events, discussion groups taking place on a regular basis. So in order to keep up with all this information, I would urge you guys to, if you are on Facebook, to join us our community page called FTI Village, and like our Facebook page called Frontier Technology Institute. And if you're on Instagram or on LinkedIn, please join our social media page that goes by the same name.
Great.
Yeah.
So any
Does anybody
questions
have
until
any?
now?
So I'll just quickly finish. I think I just have one. Yeah, I just have this last slide going on. So
Okay.
finally, if you have any queries that you think needs to be addressed as soon as possible, and that it cannot be shared publicly, anything that you feel uh, needs to be urgently addressed, you can either email it to us on that email address mentioned, queries@frontiertechnologyinstitute.com, or you can directly reach out to us via WhatsApp or call or SMS. Um, the number is given right there. So this is only and solely for inquiries or questions that you feel cannot be shared publicly. So, or if you feel that it needs to be addressed urgently. So you can feel free to reach out to us via that email or that contact number. I have direct access to that email and that contact number, so you can, you know, send your queries in confidence. So before I move on and pass on to Abrar, I would like to thank you for listening to my presentation, and I really, really hope that you learned a little bit about FTI, and you really enjoyed it. And let me know if you have any questions.
Fine. So let's go ahead.
I think Abrar, yeah, you can take over. So
Sure.
thank you everyone. Thank you for your time, and I would like to now invite Abrar to take over the presentation.
Right. So I'll share my screen. Let me share my screen. Great. So welcome everyone from my side, and assalamu alaikum. Uh, so I'll just introduce myself first, right? We'll move on to the course later. So um, I'm an MBA from IBA, and my background is from sales and marketing. So quite surprisingly, you would wonder why and how this guy landed up in analytics. I had, you can say, interest with numbers and data. I was a techie at heart, used to tinker around with technology at home with computers and gadgets. And I had a distinction in further maths and stats in O and A levels. So I guess, yeah, that's where I found my home when I started working in analytics. So I started off my career in FMCG, uh, analytics career in FMCG. Though I was in sales and marketing, I was working in Dolman, but then I got this opportunity in Saudi where I was selected as a business analyst uh, in the analytics department for Binzagar, which is basically an exclusive distributor for Unilever uh, in Saudi Arabia. So that was where I got trained on analytics. Uh, I used to work on ad hoc analysis initially, where senior management would ask questions like, uh, how much space do we need in a van, or what kind of SKUs do we need to place in a van, or what are our key customers, or where should we open the next warehouse, or which SKUs are key to our sales, how much incentive should we give to a salesman, what are the parameters that we should drive to drive sales. Now, these are all sales related, but then in the future, when we sorted out sales analytics, the company moved on towards operations as well, where questions such as, how much big a warehouse should be, which SKUs are getting expired on a regular basis, which of the resources are performing well, which of them are not performing well, and then how quickly does a stock move within the warehouse, how quickly does it get loaded on the warehouse, and how quickly does it get taken out from the warehouse towards the customer. From operations we moved on to finance, and when we looked at which expenses are going out of budget most of the time, and where are we incurring losses, which cost elements are huge in numbers, huge in proportion, and they should be reduced. How much over-indexed are we in cost elements? Which of the branches are making a loss? Which business units are making a loss? Then we moved on to HR as well, where how quickly does the recruitment function hire a resource? What's the time that they take from the first interview to the final offer, right? So you can see that analytics was going across all the business functions. So you can see that data and analytics has usage across all the fields, across all the businesses, across all the institutes. So having that much exposure to data, then when I moved back to Pakistan, I also started uh, engaging myself in tech-related fields, where data science was more coming into play. Initially, I was though going into analytics, but then that analytics was usually linked to Excel and dashboarding, and using what if tools on Excel. But then, yes, as technology was moving further, you would have databases coming in play and predictive models coming in play. Um, so there was a high need for me to uh, venture into such areas as well. So I did a certification from IBA in big data and analytics, which also got me introduced in FTI. Actually, our my course tutor, Dr. Tariq Mahmood, introduced me to Konain, and I got connected to him and got selected as a teacher here. I also did some online certifications on Data Camp and on edX, which gave me more knowledge about um, data science. So I learned a lot through trial and error, and this entire certification is geared towards uh, minimizing that trial and error that a student goes through while going through a journey in data science. We've designed this certification so that you get most of the knowledge charted out, sorted out in your mind about this field, so that you can select your future. You can design your vision towards your career in data science, and where do you want to land, in which part do you want to focus in. So so this initial module will basically introduce you, familiarize you with the different concepts of data science, and how to draft a data science problem, how to identify it, how to document it, and then how to move it along its life cycle. So there is a major stress on in this initial module on the data science life cycle, which will be part of our first two sessions today and tomorrow, and probably in the next week as well, in the first session. So once we're done with that, then we'll move on to hands-on and a little bit of introductory uh, practical work on Python. So you will be introduced to some of the basic libraries, fundamental libraries, uh, such as pandas, matplotlib, and um, Seaborn. You'll work on them and get a little familiarity with Jupyter notebooks, so that once you're finished up with this module, you'll be ready to take on advanced knowledge on machine learning and EDA, and exploratory data analysis, and so on and so forth. Whatever the path that Konain discussed with us, you'll be ready to take on the future modules. So yes, as discussed, uh, the objective of this module is to familiarize you with the foundation, so lay the brickwork of data science. and we'll do that through a huge amount of exercises, quizzes in class, and also home assignments, so that you get the full exposure, a 360-degree view of this field, right? And understand how you approach problems related to data science. So the sessions are designed weekly, right? The first two sessions are in the first week. We'll have two sessions per week, and every week has a theme to it. And the first week, the theme is fundamentals, right? We discuss the basic concepts, and then we move on to data wrangling, data modeling, and basic Python, right? That's the second week. And yes, we continue with data wrangling in the third week, where we focus on NumPy and Pandas library, and then we move on to the visualizations, right? That will be the final week. We'll squeeze in SQL within this time frame. That depends on how we progress, uh, and we'll let you know on how we can squeeze that in. It all depends on the interactions with you, because all this this entire certification is uh, an interactive one, right? And we encourage a lot of participation, because we can only learn while we contribute our ideas together, especially in this fundamental course, where you guys who have eyes on their own fields and are working, you can identify problems that you have. As you learn, you will be able to define problems in the areas that you're working in. So if there's a finance major, he can identify things like credit scoring. There's a sales guy, he can identify things like sales forecasting. And if there's a guy from medicine, you can identify things like diagnosis. How can we do predictive diagnosis through data science? So it will be a healthy exchange of ideas when people from diverse backgrounds, and we'll explore that even in this session when we'll have your introductions as well. We'll see that people on this forum are coming from different backgrounds, because we encourage people from different backgrounds to come and join this certification, as it hasn't remained restricted to techies only. We definitely encourage people from various backgrounds so that they can draft problems in that area. Coding is of no issue. You'll see that the solutions coming up in the world today, you'll see that they are getting less dependent on code. And even if you require coding, you can always take help from people who are techies. The main skill to learn from this certification is to understand what data science is and how it can be applied to various situations that we are in, right? So just as an exercise, and I would love some one to or a few people to contribute as well, that how do you define data science? You can take some time. Meanwhile, we can have a little introduction from Ayman as well, who has also joined us. She'll give us an introduction, and we'll take 5 minutes. And within that 5 minutes, we'll have an introduction and discussion. And meanwhile, you can also define a data science problem you can define data science in your mind, and then we'll get to the definition, right? So Ayman, uh, please grace us with your introduction. Ayman, I guess you're on mute.
Yeah, I'll join in a minute.
Sure, sure. So yeah, you can think about data science, take it as a pop quiz, an unmarked pop quiz, right? So just write down, or just gather your thoughts on whatever you think about data science until now, and then you can raise your hand on through Zoom. So there's a function here. You can raise your hand and we'll ask someone to contribute. So yeah, anyone who wants to share their thoughts on what they think about data science?
Can I?
Yeah, sure. Who's this?
Uh, I am Mohammed. मेरे हिसाब से डेटा साइंस वो है कि आप एक डेटा यानी कलेक्ट करते हैं किसी जगह पे और उसको विजुलाइज करवाएंगे किसी इस तरीके से कि यूजर को अच्छी तरीके से दिखे या फिर अच्छी तरीके से उसको समझ में आए। जैसे मेरी ऑर्गेनाइजेशन में है कि सेल्स कैसे हो रही है, सेल्स के हिसाब से उनका कमीशन कैसे बन रहा है, उनका कमीशन के हिसाब से उनका प्रॉफिट यानी कंपनी को प्रॉफिट क्या हो रहा है।
Good.
ये मेरे हिसाब से यानी डेटा साइंस
Okay. Okay.
बस मैं इतना ही बोल सकता हूँ।
Okay. No, no, that's part of data science. बिल्कुल सही कहा आपने कि data से visualization बनाना. Though more specifically, this is business intelligence, but yes, it's also part of data science. So Tayyib Kareem, you raised your hand. If you can share your thoughts.
Yes, sir. Assalamu alaikum.
Waalaikum
Uh,
salam.
Actually, data science is something which you can first of all you get the data from a company, and then you can use it according to the needs of that company. Like first of all, you will visualize it and then analyze it. That what data do you need, and then according to your I would say uh, according to your company's needs for profits, you use that data to get that or to reach that. This is what I understand it.
Very nice, very nice. That's a more generalized definition, which does cover a good amount of work done on data science. Yes, someone else, Talal Sheikh.
Yes, I think data science has to do more with the what do you call that? It has more to do with collecting different data from marketing. From a marketing perspective, it involves taking some sample points where you can like collect those points and amalgamate and glean insights from those points. Like for example, I go to a store and there someone is there selling different samples. So when they sell those samples, they're giving out free samples. So from those samples, you can like uh, you can see how many people are buying into those samples and how many people are like leaving them away, and then you can plot a graph and see how successful your product launch or product that if you're part of that company in the marketing department, you can see how well that product is performing and seeing that how well it like goes.
Good,
um,
good.
I think.
So that's good. Talal, what you've defined is actually a use case for data science. And yes,
Mm,
you're applying the framework of data science on a specific example. Very nice, very nice.
yes,
Maheen.
thank you.
Yes, I think data science basically involves gathering some relevant data which will help you in answering your business questions, and then you apply some analytical techniques on that data to to recognize hidden patterns in that data, so that it will help you in increasing your profit, business profit, and it will help you in making future predictions and forecasting. So
Very
I
good,
guess
very good. Quite an extensive definition. That's nice. Kulsum.
सर आई थिंक डेटा साइंस में पहला स्टेप जो होगा वो डेटा क्लीनिंग का होता है। we have to clean the data, take out the null values, and we have to take out the meaningful data. उसमें बहुत सारा data होता है, उसमें से पहले extract करना होता है जो हमारे काम का data होता है. Then we will draw the graphs and analyze the data and visualization, everything.
Very nice, very nice. So what you're actually defining is or describing is actually the data science life cycle or the data science methodology. That's true. That's true. That you have to clean the data, and we'll get to that. So when I talk about data science life cycle, we'll go through all the stages of like a standard process that you go through whenever you are working on a data science problem. So yeah, very nice, very nice. So let's first get to the definition, and then we'll come to Ayman. And
Yes, sir, I'm here. Sorry
let
for the
yeah, good, but let's just
again.
otherwise people will be distracted about they're now more geared towards knowing what data science is
Yeah.
finally. So yeah, so so yeah, data science in general, if you just define it in a phrase, is getting insights from data, right? And usually this is um defined as a business or any institute, if they realize that they need to change, if they realize that something is wrong, that they need to change something, right? So that's the need that they feel, that there is a need to do some analytics and some data science, right? When you have that need, you realize that, let me plan out my data and do some analysis to get insights. But then insights at the end is just a piece of information that you get. But if you don't action it, it's just lying there. It's just like a diamond in a coal mine, right? So you need to action it as well. So, and it's in business context, right? So the things that we have kept on bold here is that using scientific exploration on data to extract meaning, insights, right, in a context. Out of context, analysis is just, analysis paralysis, that you do analysis just for the sake of analysis. That doesn't really make much sense. You should do analysis to a certain context, to address a certain problem, to define a strategy, to find a solution for a business, to get value out of something, to create business value. Then only data science is successful. Otherwise, we see 90% of the data science projects failing because they don't really address any problem. So when we come to data science life cycle, we will highlight that in more detail when we look at the data science process. So in brief, it is an amalgamation of three fields. And of course, computer science is there, and you see maths and statistics there, and you see subject matter expertise. Of course, data science requires some level of coding, some level of programming skills. So yes, that's computer science, and it requires maths and stats, and it needs to be done in a context. Now, it can be a medical context, then the subject matter expertise becomes medicine. Or if it's a marketing context, then it requires a marketing guy to be a subject matter expert. If it's a sales problem, then you need a sales guy to be a subject matter expert, right? So here we should realize that data science is not a one man's job. It's a team's job, right? So in any data science concern, whether it is a department in a company or it is a data science consultancy, such as the place that I'm working at, Love for Data, you will have people from different backgrounds, right? You will have people who have done bachelor's and master's and PhDs in computer science and data science, and those guys are usually techies, right? They're very essential. You need coders, you need expert people who have that level of uh, tech skills to address any data science problem. But then you also need people who are good in maths and stats. And yes, people who've done PhDs in data science or who've done masters in applied statistics, they are good in maths and stats, right? You need to understand. You need so people. who come from that background, what do they do? They understand a problem, they understand an algorithm, right? And its nitty-gritties, the stats behind it, and can tweak those models uh, to suit the situation and the data. And subject matter expert, as we all know that how it works. Different problems, different subject matter experts you need, right? If it's a finance problem, credit scoring problem, you need a banker or a financial expert to be part of the team. We encourage diverse
So,
background.
I'm sorry to interrupt, but I have just one question. Will these slides be available to
Sure, sure,
download?
sure. We're
All
open
right.
about sharing and all. So we are also recording the session. You have recording available. You will have slides available. So that's not an issue. Okay.
All right. Thank you. Thank you so much.
Fine. So these three fields come into play. Of course, people who are master of all these three fields, of course, they're unicorns, right? You won't get many resources who are experts in all three, right? They are unicorns, and wherever they are, people are ready to hunt them down and to value them, keep them in a cage, right? So, but then yes, it's good to have intersections of different skill sets, right? And that's what we encourage when we encourage people from diverse backgrounds, so that we can have more hybrids uh, rather than polarized resources in this field, right? So it always helps if there is a business guy who also knows about technology and the limitations of data and how to play with it, so that he is more realistic about running projects related to analytics and data science. So, and it definitely people who are uh, good in coding and technology, it's always nice for them to learn a bit about business and the limitations of business and their needs and requirements. So, it's good to bridge the gap. So that's why we target people who are from diverse backgrounds, so that we can have more hybrids who can further this field in a better way. So why has data science used? We see that data science jobs and searches and resources have exponentially increased. And why is that happening? Because we see that you know data is becoming more growing exponentially, right? And that's the hottest asset for any company. So data, internal data, external data, data about uh, uh, the industry in general, about competitors, it's all good, right? So data is exponentially increasing. We see that devices are coming around, such as fitness trackers or even smartphones and sensors, which are tracking different um, areas, right, on a regular basis. Now, previously, sales used to happen over pen and paper, where a salesman would take orders on a paper invoice. Now, the salesman is using tablets and smartphones while taking orders at an outlet. So, besides sales, imagine the different types of data sets that can be gathered by that tablet. The salesman can take pictures from that phone. The salesman's location can be tracked on the phone. The customer's location can also be tracked on the phone, right? And the salesman can also ask a survey from a customer on the phone. So, you know, and if there are other sensors, such as if he's moving in a car, the car can also have a GPS tracker, as well as uh, the odometer and other sensors, such as the health of the car. So those sensors can also send in data. So imagine the wealth of data that is uh, being reported to an organization. Now, all those tables and tables of data, that rich data, if it stays in the form of tables, it's of no use. It can only be used if you use analytics to it, if you can summarize it, if you can visualize it, if you can do predictions on it, if you can find rules which can signal different decisions. So
So what
if
about social media and all that? like Facebook, the things that we get, the reactions, the likes, and all that. Does that come into the realm of data science, or is it a little bit different? Is there another aspect to it?
So wherever there is data, there is data science. So even in social media, if
Hmm.
there is a finance firm, let's say you have a bank, and the bank
All right.
has customers, and the bank entertains loan applications. And if a person
Hmm.
applies for a loan and a bank has access to the loan applicant's social media profile, the bank can study
Hmm.
the network of that loan applicant and see if that person has in his connection defaulters, right? Previously defaulted customers. If they are there in the new customers network, the bank can have a reasonable level of doubt that this customer might also default, right? So so social media, though previously the data was more free flowing, but there are more restrictions on reading data from social media, right? Facebook and LinkedIn and other social media platforms, they have now put restrictions. But still, you can say that uh, you can use this data to even understand a person's likes and dislikes, right? Make a customer profile out of it, and you can even find out new customers which have a high rate of adoption for your product. Let's say you are offering a new kind of fruit juice, and you need a certain profile of customers which are more active, which are more vital in their lifestyles, which have uh, you know unique choices. You can study a person's Facebook profile and can see with a reasonable level of doubt that these are your relevant customers. So target marketing can also be uh, uh, addressed on social media. So wherever there is data, there is data science. We can't restrict our thinking that data science is for these fields, these areas, these technologies. It's pervasive. Wherever you think there is data, you can apply data science. So moving on, there's some buzzwords or some terminologies that we should clarify. But yeah, let's first have Ayman's introduction. I'm sorry I got carried away. Ayman, if you can, uh, let's know.
It is okay. They'll get to know me later.
Yeah,
We
no, no.
if it's breaking the tempo of
So
the class.
Ayman, no, I'm not breaking it.
No, if I am
It'll,
breaking the tempo of the class, it's fine.
you already have. Huh? That's,
Okay. Okay. So I'm Ayman Rehan. I am very glad to have you all here today. I am the program manager at FTI. I graduated from Bilkent University in 2019, electrical and electronics engineering. I have been with FTI since an year, and the journey so far has been amazing, and the way we are expanding, and and the quality that we are providing over here, it is improving day by day, and what we really care is that we keep keep aligned with what is happening in the industry, and even in the academics we make sure that whatever practical work we make you do over here, you get to use it somewhere in your university maybe, or wherever you are working. And this time I'm glad that we have balance. I guess there are a number of girls in this cohort. So yeah, so basically I'm a data scientist by profession, and in this cohort for you, and the academic part that I am dealing over here is to ensure that whatever we offer is up to date, and whatever feedbacks you guys have about, or whatever like ideas you have about data science, we are here to entertain them. And we are closely also expanding, so we closely monitor the progress of each and every student and their vigor as well, because we do have opportunities for them to offer as they take our certification and show interest. So yeah, so any queries you have or any feedback you have, because there are people that join us from diverse backgrounds, and we try to cover a lot of things, even like in like nothing, no certification offers as much content as we offer. So sometimes it might be hard for people who are from non-tech background, because they might feel a bit overwhelmed in the first few sessions or the first few modules. So we do have now regular practical sessions apart from the classes as well. So whoever needs extra help, or whoever has some extra queries to ask, or so they can always ask in those practical sessions. And in those practical sessions we try to do use cases from the industries as well, so that people can have a better idea of understanding the data science problem, and they can see where whatever they're learning here, how it can be applied. So I think I have covered pretty much everything that comes under my scope. Yeah, so if anyone has any questions, they can ask. Or if Sir Abrar, I have missed anything from my role, because I was not expecting to break the tempo of your session. So I was like, okay, they'll know me anyways from the sessions, practical sessions and module 3.
No, no, this is an introductory session, right? So that the tempo, you have contributed towards the tempo. We'll also have your introduction as well for each of the students. Let me just go through a few slides and then we'll move on to your introductions, because of course it's good to know from each student's background, which would help us uh, in understanding this field further, because that's, even we've received students from even medicine, from geology, from oil and gas exploration, from astrophysics, so from electronics, and each student has made us learn further about this field. Even though we are teaching it, but this teaching, I won't say it's teaching. This platform is for learning for all of us. So it helps a lot when someone comes in from with a unique problem related to their field, and it opens our eyes that this is also another use case for data science. So inshallah, this is going to be a learning platform, a rich learning platform for all of us. So moving ahead, uh, data is the gold now, right? It has replaced oil. Whoever has data has wealth, right? And the best possible use of that wealth is to get value out of it, right? To move it, to mobilize it in the right direction, to get decisions out of it, right? If it's lying there for no use, then you might as well not have it. But the only reason to get data, you don't brag about having 1 terabyte of data, right? You brag about that I'm getting value out of that data. I have made $1,000, or I have made $100,000 of profit, a difference in my profit by using data, right? So even if your hard disk is full of data, that doesn't mean you're rich. You're only rich when you make value out of it. And that's what we learn in this course. So there's some buzzwords and terminologies that get used across this course and in this field. We'll touch upon that in the slide. Okay, we have, I think, a question. Relevance is key. Okay, that's so. Yeah, whoever wants to ask a question, it's best you raise your hand, right? I won't be looking at the chat right now. It breaks my flow. So I'll rely on you guys to raise your hand, and I'll uh, take your name, and then you can contribute. So buzzwords, machine learning. Very simply put, even if you don't look at this description, very simply put is that what is learning? Learning is, uh, let's say you're doing a task, right? You are cutting a tree, and you learn when you learn. So initially you start off by just cutting it, and probably you're not holding the axe in the right angle. Probably you're using a blunt axe, right? And with experience, you learn. And you realize that, yes, I'm not cutting it, I'm not hitting the tree at the right angle, so probably I should change it, right? You realize, and you adjust your axe, you sharpen it, so you learn. And then you make your performance at that task becomes better, right? You cut trees faster, right? And that's what machine learning is, that you improve your performance on a task through experience, right? So there are three important elements here: the task, the experience, and the improvement in performance, right? In machine learning, the data, the historical data is experience. Your data trains a machine, right? So you use data to train a machine to perform a task better, right? So let's say sales forecasting is your task, right? You will feed in data about, let's say, past 3 years, past 5 years, to improve a machine's performance in making sales predictions better, right? So that's what machine learning is all about. The cloud. So if you're not using your own local systems, of course you'll have to use a terminal. Right now, what's a terminal? Usually any machine which doesn't have much processing resources, it's just used to access another system, right? So if I'm using my laptop, let's say my laptop has a very meager resource of i3 processor, and it has 4 GB RAM, and it has only 500 GB hard disk with 4 GB RAM, let's say. So it's a very, it's not such a good machine, right? But I'm using it as a terminal to access another machine, which is on the cloud. Now the cloud can be AWS, Amazon Web Services, can be Microsoft Azure, can be anything, right? But it's a system made online for use by someone else, right? So it's a subscribed system. You subscribe to that service, right? And you use uh, that service, and through that service you access another machine, right? And you can define that machine by yourself. You define your own requirements. Let's say you wanted a 16 GB RAM, and an i7 or a high-end processor with a graphical processing unit of 8 GB with 1 terabyte of hard disk, right? You can define that on Amazon Web Services. So you use your laptop to access that system. And why do you have to use cloud? Because cloud systems are scalable. Now, you can't change your desktop or laptop on the fly. If you want to increase the RAM, you'll have to probably call someone usually to put new chips inside, or you'll have to take your machine to a vendor and get that changed. But it takes a lot of time, right? Usually it will take a day or two for you to get that sorted out. And probably you won't need that system for a long time. Let's say you have a heavy code which you want to run for about an hour, and you'll be done with it, and you just need results for that. So why improve your resources to such an extent? Why commit your money to such an extent? So what you do, you'll just subscribe to a service on the cloud, run that code through your system, and then switch that server off. So you'll just be subscribing to that computer for a certain period of time. Instead of instead of buying it, you're just taking it on rent for the time that you needed it. So probably it might cost you around $30 instead of $1,000. So the cloud is a flexible place where you can subscribe to resources, you can subscribe to softwares, right? Even Office 365 is something which you're subscribing to, right? So it's a very flexible place where you can subscribe and get things done. Then comes deep learning. Deep learning is a branch of machine learning which behaves like a human brain, and usually it is a neural network, which is a type of an algorithm, and which has more than 2 hidden layers, right? So you'll get to that when you are working with supervised learning. When you are learning that in module 3, you'll be able to understand this field better. It is a rich field, and you can also see that there are PhDs who specialize in this field of deep learning, where they study the behavior of neural networks and how to tweak them, how to adjust them. So it's a comprehensive field on its own. There are books written specifically on deep learning. So it's even though it's a branch of machine learning, but it's a field on its own. Then you have data mining, which the definition of that is a little similar to data science. It's using data to identify patterns and relationships and generate new information. In my mind, how I separate the two is that, data science is getting insights out of data, while data mining is getting the right data, querying the right data from the raw data that you have. So, you filter data, you organize data, you model data, all of that you're doing in data mining. So data mining is an essential part of data science. Big data is a very fancy word which at times people use in the wrong way, but it's big data is reached. So not all data is big data. At times you differentiate between the regular data and big data, and there are certain parameters that differentiate big data from the regular data or small data, and those are that it should be high in volume, and it should be different in variety, right? So, and you know, there might be data about sales, about inventory, about operations, about website traffic. So there are different varieties of data, right? And then you have veracity, where you have data of different types. You have data in tables, you have data in audio form, you have data in video. So data has become a very uh, diverse term. It's not just the numbers and characters residing in Excel sheets. It can be anything digitized. It can be video, it can be audio, it can be pictures, it can be signals from sensors, it can be documents, right? So it can be anything that you capture through digital means. You can treat it as data, right?
I think the videos on YouTube, they may be categorized in this category. So
True,
they might
true.
be part of big data because there are massive. It's a massive volume, but by definition, there's a massive volume of billions of hours of data is being uploaded every day. So I
Yeah,
think that is part of big data.
true, true, true. So, you can also see if you switch on captions, right, on YouTube. Do you really think that those captions are written by a human? Not necessarily. Those captions are usually listened to by voice recognition systems, which are basically
I
machine
think
learning systems.
it's a combination of deep learning and machine learning that
True,
brings it out, brings
true,
those captions.
true, true. That's true. That's true. So data can be anything. And in big data, you have volume, you have variety, you have veracity, right? Which, uh, and then velocity. That is the speed of data at which it's arriving. So imagine Daraz, which is an e-commerce platform. Imagine the the speed at which data is arriving. That the number of people who are visiting that website, and uh, let alone sales. Besides sales, though it's still a huge sales platform, but even a lot of data gets captured even if you don't purchase anything. So what kind of data gets captured? The products that you are viewing, the products that you put in your cart, but you don't buy them, right? Products that you put on your wish list, products that you scroll through, products that you check for details. So all of that gets recorded by the RAS, and those can be fed into recommendation systems, which can send you emails, send you SMS about discounts on products that you've viewed, right? So that makes your marketing more relevant. So velocity, volume, variety, and veracity. Those now there are more V's. So these are called the 4 V's of big data. At times you have also 9 V's of big data, but usually the basic are these four, which qualify that now when all of these four are ticked off, you can say that you're working with big data. So usually the problems that we face, 70% or 80% of them usually are regular data or small data, and it's fine. There's nothing wrong with that. Uh, because big data, then when that challenge comes in, you'll have different frameworks, different technologies that would come into play, even though machine learning remains the same and data science remains the same, but you'll need technologies to handle that data. Now, what kind of technologies are these? We won't touch upon that in this certification, but you can also read upon that, things like distributed computing, Hadoop, and NoSQL databases. You can search upon them and try to understand this field. We won't be touching much on this in the courses to come. We'll mainly focus towards machine learning and data science problems. Then cognitive learning, similar to neural networks, but a little more advanced, is how to make a model think like a human mind. It's more towards AI. We won't be touching much on it, right? But that's just a term which we just wanted to explore. Algorithm development, more so what is an algorithm? So, if anyone can raise their hand and let just, if you can simplify the definition of algorithm, we'd be happy to learn. So anyone who wants to contribute?
I think it's in very simplistic terms, it's an equation that that like makes different the equation that you feed the data in to gain information from it. I think there's a role of an equation and the algorithm.
Sure. Zahida, do you have anything?
Algorithm is a step-by-step finite method to solve a particular problem.
Good. That's good. Mahin?
Yes, it's basically a set of instructions according to which anyone can perform a task. Basically, computers, there are many algorithms on which computer works. So, in simplest words, set of instructions to tell computer how to do a task.
True. So nicely put. Algorithm is a set of instructions it can also be in Excel. You don't have to really work on Jupyter notebooks to make an algorithm. You can also make an algorithm by using a series of if statements, right? So, if score is greater than 75, pass. If less than 75, fail. That's a basic algorithm that you've made. You made a rule to, make a computer decide on what to do if you get an input. So if a computer gets an input of 60, it'll pass it as fail. And if a person gets an input as 80, he'll pass it as pass. Yeah. So algorithm development, now there are advanced forms of algorithms, right? Now this if a statement is basically a rule that you a threshold based rule that you've created. But then what's the beauty of data science and machine learning is that these rules are created by the machine itself. You don't have to manually figure out rules, right? You have different algorithms which study data and find out the significant variables, and create rules from those variables, right? So there's like, the most intuitive one is decision tree, which basically takes in all the features, all the inputs, right, and makes branches out of it. That if it's greater than 75, and if it's the subject is maths, and it's uh, in class 7, then you are pass, right? So different subjects might have different passing grades, right? So you can do that. Or more so about loan prediction, that if a person is living in a rented apartment and his salary is less than 50,000, and he's living in Sadr, and he lives in with his parents, and he has 2 children, then there's a high chance of him not paying back on loan. Or if a person is living in owned apartment in Sadr, let's say his income is more than 50,000, and he is living by himself, then it's a high chance of him paying back. So these rules. So you can have if statements, right? You can still have rules, and you'll say that, if I can do it in Excel, why do I have to do it in Jupyter Notebook? But then the thing is, these rules though are something which you made in Excel, but algorithms can be tweaked to figure out rules by themselves. They use data to figure out rules by themselves, right? And some of the algorithms are black box that you can't open them and see what rules they've made. Things like neural networks, they won't reveal what's inside, but you can test the results whether they are accurate or not, but you can't see how they are working in. But there are some algorithms which are not black box, right? Decision tree, which you can, graphically even represent how the decision tree is working, how it's making decisions through data, what rules has it created through data, right? Mahin, do you have a
Uh,
question? Okay. Talal, yeah.
yeah, I have a question. Can you further explain a little bit what you mean by neural networks? Because I'm really new to this and I really want to learn about
We'll get to
neural
that.
networks.
So all in good time. We'll get to
Oh,
that when
all right.
we go into the details. Okay. So then we have pattern recognition, right? And simple. You see a pattern now. Default is also a pattern, right? A certain segment. So you don't make rules based on specific examples, and that's what we have all contested a lot with our clients, right? Because at times clients come in that, I have a guy who is a student and he is also married. I think he's lying. That specific person is lying. So there's a high chance of default. So why don't you make a rule out of it? So we say, no, we don't make rules on specific examples. We generalize, right? Which means that we uh, uh, create patterns, right? That usually, usually people who are students, do they default? Probably not. Is there a chance that a student is married? There's a certain chance, yes, if he is in his final year or something, or probably he got married earlier, but then, or he got married and then later on became a student, right? Probably he's a PhD student. So uh, you can't say that, a student who's married is definitely going to default, right? Probably not a high chance of him defaulting. So, it's all about chances. But yes, if a person is living in a rented apartment, salary less than 50,000, then the algorithm starts calculating probability that, there's the chances increasing. If you add on more variables, like, if he's living in a rented apartment which has a cost of more than 60,000, right? His rent is more than his income, then, again, there's a high chance of him defaulting, right? So the more variables, significant variables you add, the more uh, accurate your model can become, right? So these rules, these combination of rules are created by algorithm, right? You can study them, you can tweak them, right? And understand them. You don't have to manually, and the beauty of this is you don't have to manually key in rules, right? The machine recommends rules by itself. Neural network, again, mimics the human brain. It's a network of nodes. We'll study that in detail when in the courses to come. So for now, we'll just say it's one type of algorithm which has neurons in it, right? Nodes in it. And each node basically passes a signal of yes and no. And each node takes in data. And you can say that there are hundreds of nodes connected to each other, and they keep passing signals to each other, and finally they give a result, right? So that's what basically a neural network is. Each algorithm has its own structure, has its own parameters. A decision tree basically is like a tree diagram that you make, right? Random forest is like mini trees, and you make a let's say you make 100 trees and you get decisions out of those 100 trees, and then you take a majority vote. Let's say 59 out of 100 trees are saying that this person is going to default, then you probably would say that this person is going to default, right? So random forest is like a combination of trees. So, every algorithm has its own nature, its own inputs, right? And we'll study that during this certification, and we'll try to use them in our different scenarios, right?
Sir, I have a question.
Yeah, please go ahead.
Sir, what is the difference between ANN and CNN?
We'll get to that all in good time, right? So let's not skip to something which is advanced, right? We'll go at it at the right pace. We're just going through introductions, and when we get to algorithms, that's probably something which you can ask in module 3, right? And probably by that time you would be clear already. Okay. So data scientist, as in data science, is required to know the different multiple disciplines that we have, right? And which is maths and stats, programming, database, communication, visualization, domain knowledge, right? Again, having all these three is basically a unicorn, difficult to have, rare resources. But yes, having hybrids, any two of these three fields is necessary. I say three because the fourth one, communication and visualization, I consider a must. It's something which everyone should have, so that we're able to communicate the results of the analysis that we are getting, document them properly, and get buy-in from clients. That's something which is a must, mandatory thing that every data scientist should have, right? So before moving on to history, and probably we'll do that in the next session, let's move on to introductions from all of you. And I would like, I'll call out the names. So so the first one in my list is appearing as a dash. If you can rewrite your name so that I can know your name through the display in participants. So if you know who you are, then you can start off your introduction, or we can move on to someone else. So let's move on. Probably we'll figure out who that person is later on. Ahmed Khan.
Yes, sir.
Yeah, you can give us a brief intro about yourself, your background, where you're from.
Okay. My name is Mohammed Ahmed and I am from Karachi. I studied BS Computer Engineering from Sir Syed University, and I am now working in a NBB funds market. NBB funds, subsidiary of NBP, as a Oracle Apex developer.
Great. And what's your objective behind doing this course?
I want to learn Python. My main purpose to learn data science is to learn Python.
Great. Fine, let's move ahead. Ali Asfar.
Hi everyone. Assalamu alaikum. My career is mostly with supply chain, and currently I am working in Agha University Hospital as assistant manager purchase, and I did my master's in applied mathematics. Even I have the educational background in mathematics and statistics, but unfortunately I never did any experience in computer programming or work like computer programming or academic background. But the main purpose of this course doing is to do something extra, which I already know something about it because of my academic background. So I learned the data science. Thank you.
Great. So Let's move ahead. Athar Saab.
अस्सलाम वालेकुम। बस मेरी पैदाइश सखर की है, बस कोविड की वजह से मसरूफियत इतनी नहीं है, तो मैंने कहा ये कोर्स कर लिया जाए। तो ये है कि कुछ चीजें सुनी है तो कुछ जान लेंगे, इससे ज्यादा अभी इंशाल्लाह उम्मीद है कि जो सारे दोस्त हैं उनसे मैं सीखूंगा, और मैं सीखने के लिए आया हूँ, और दैट्स द मेन थिंग।
चलो, और आपकी फील्ड?
मैंने बीएससी की हुई है, बस एक और छोटी सी नौकरी करता हूँ, ऐसी कोई खास मसरूफ नहीं। पेशावर यूनिवर्सिटी से बीएससी की हुई है, इससे ज्यादा कोई वो नहीं है।
सही सही, माशाल्लाह। So, Ms. Fabiha.
Hello, Assalamualaikum.
Walaikum salam.
I am a commerce graduate from Karachi University. Looking forward to learn something new. That's not doing a job currently, but
Great.
want to do. Thanks.
Great. Maheen.
I have been recently graduated from NAD as a software engineer, and basically my expertise lies in web development. I'm a full stack developer, and I have done some internships in that field, in that area, but not currently doing job anywhere. I'm doing job hunting nowadays, and basically I'm doing this course because I'm interested in data science and doing masters in future.
Great.
That's why I'm doing.
Perfect, perfect. Muneem Saab.
Assalamualaikum. Am I audible?
Yep, you are.
Okay. So basically, I am from Gujranwala, and I think I might be the only person here which is not graduated yet, because I'm in my final year of bachelor's in mechanical from University Islamabad.
Perfect.
Or the reason for taking this course is that if option given me again to choose my degree program, I might switch to software rather than picking mechanical again. And I also have I have a vision of doing masters in robotics. That's why I opted this field in this course.
Great, great. Robotics is an interesting field, and it's also gaining ground due to advancements in AI. Very nice, very nice. Malahat, Miss Malahat, if you can.
Assalamualaikum.
Walaikum
I'm Malahat, and I'm from Lahore. I've currently graduated from University of Central Punjab as a computer scientist, and currently I'm hunting jobs and exploring my area of interest in different fields and doing some certifications. That's it.
Great, great. Atif Saab.
Assalamualaikum.
Walaikum salam.
Hello.
Ji, you're audible. You can go ahead.
I am working in MCBR Habib in QA department as an assistant manager.
Great.
For my personal test, I am taking this course. That's why I'm trying.
Well, your voice is breaking a bit.
Hello.
Yeah.
Okay. So I'm from Karachi, and my field is in finance, finance, and also I'm working in MCBR Habib as a QA department, quality assurance department as an assistant manager.
Great, 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 great. So, Talal Saab.
Yeah, my name is Talal, and I've done my bachelor's from IBA in 2016. So I'm from the same university as you. I've done my bachelor's in marketing, and from that point of view, the reason I took this course is to get a certification in data science, because I've been like hunting jobs for the past 2-3 months. एंड उसके अलावा जो है मैंने पहले जो है मेरा एक्सपीरियंस उसमें है कंटेंट राइटिंग एंड मार्केटिंग के अंदर, तो उस हिसाब से जो है आई थिंक द नेक्स्ट लॉजिकल स्टेप फॉर मी is going towards data mining, data, becoming a data scientist, um, like while pursuing my goals of marketing. एंड जो सोशल मीडिया में उस वक्त इतना ज़्यादा कर रहा था, तो उसमें ये था कि आई वांट टू बिकम सोशल मीडिया के अंदर मुझे थोड़ा बहुत जो है वो करना है, क्योंकि मेरा एक्सपीरियंस उस तरफ भी है। आई वर्क इन बोल एंड मेरा एक्सपीरियंस जो है वो उस तरफ है, एंड आई would like to understand and go into the depth of like data science, और किस तरह जो है वो सारी चीज़ें ये जिस पे मैं काम कर चुका हूँ वो किस तरह अंदर से ऑपरेट किस तरह करती हैं। आई रियली वांट टू लर्न दैट। तो ये एक तरह से पर्सनल में ग्रूमिंग भी होगी, and I would get to learn more along the way. So that's what I think is the main objective for me, at least.
Great, great, makes sense. Talha. You have chat. Okay, Salah has microphone issues. Fine, you can sort it out later, because, yeah, one thing which I would like to mention is that this is supposed to be a highly interactive course, and we can only enjoy when we can have this exchange of ideas. So I would encourage all of you to share your thoughts whenever you have. Don't suppress them. Share your ideas, share your thoughts, because that is going to help our learning. The right way is you raise your hand and I'll call out. I'll ask you guys to contribute, right? Please don't hold back. Uh, initially, in a few sessions, uh, people who are excited about sharing their ideas will run through them, but then that happens, right? We'll start highlighting people who are not as uh, excited about sharing ideas. Those will then be pointed out and you'll have to share, right? It's supposed to be an interactive course, so please do. Please share as much ideas as possible. So then we have Tayyib Kareem.
Oh, yes, sir. Well, I'm Tayyip Kareem, and I'm studying BS Accounting and Finance from PFT University. I'm in my third semester, and actually, the reason that I've chosen this data science field while continuing my studies is that finance has some relations with the data science, right? So I've heard somewhere and I've read the articles, 2 to 3 articles, that financial data scientists are what they do is that fraud detection and customer segmentation, these kinds of jobs, I really liked it. So that is why I've decided to also learn the data science in this way.
Very good. Very nice. We have Zahida Naz here. If you can share your background.
Assalamu alaikum, sir. I am from Karachi and I am currently studying software engineering from PAF KIT and in the 7th semester. And I want to study this data science course because I have heard about AI, machine learning, data science from my teachers, and they were machine learning engineer, data scientist. And later, when I studied AI in my one of the semester, then I decided that I have interest in AI. So later I studied about AI and machine learning, and then I prepared my mind that I will pursue the job in this field, and that's why I am studying this course.
Very nice. So yeah, That brings us to a close. Anyone left out can raise their hand and we can ask them because there were two people who were coming in, one as a dash, the another one as a slash. I guess those have probably that was a device issue, but if I've left someone out, please do raise your hand and we can ask you about your background. Otherwise, I'm done through the list. Fine, so let's move on. So yes, the aim of this certification, one of the prime aim is that data science and machine learning stops being a mystery, right? Because when you look at something work, right, through AI, you probably, when you're writing your email now in Gmail, it starts suggesting you words, right? On your mobile, you see that the pictures that you take, they automatically get categorized by the people that are in that photo, right? So you get suggestions that is this the person that you're talking about. When I take a picture of, let's say, my wife, and I've placed a tag on that this is my wife, then other pictures that I take wherever, in whichever photo my wife is there, it suggests that is this the same person, right? So and then when you talk about when you're writing an article and when you're uploading it on a platform, it automatically categorizes your article. Let's say if you're talking about sports and fitness, it automatically categorizes your article as fitness without you mentioning it. So these systems, now initially when you don't know, you get overwhelmed by it, or you know wowed by it, uh, and you start wondering how does it work. So the objective of this certification is to lay it out in the open, right? To stop make it stop being a mystery for you, so that whenever you're looking at something work, right, in AI and machine learning, you can think about how it's working. You can just chart it out in your mind that probably this is how it's working. My emails are getting categorized as a spam automatically through this, right? So, and the good part is when you start thinking in that way, you also start thinking about the challenges and issues that it has, the limitations that it has, and you start thinking of how to improve them, right? So that's the beauty of taking this certification and advancing your knowledge in this field, that you start thinking along those lines.
I'm a
So
really, I'm sorry to like cut you off, but I'm a real avid user of, Google Maps. And whenever I was recently on a trip to like Punjab, upper side of Punjab, and um, I saw that whenever I like took pictures of, be it the motorway or be it some other place. So whenever I put my location on, so it would automatically pick out those pictures that I took, and it would say, uh, "Did did you like your stay at this hotel, or did you like your stay at this stop or something like that?" So I think that also, you know, that's also part of this.
yeah,
That's my observation.
that's true. That's true. So AI and machine learning models are working all around us, working on our mobiles, working on our websites that we are visiting, working on systems that we interact with. So yes, um, that's a good observation. Moving on, how did it start? The history and evolution of data science. Now, this is something that you can read on, but yes, it started off as a field in computers and maths and stats, and usually, at that point in time in 70s, the systems were not sound enough. The technology that we had, the computing power that we had, so what fits in our hand today was probably fitting inside huge buildings uh, 50 years before. So, the supercomputers of those years are probably smartphones, or, the smartphones are beating them in their game 50 years ahead, right? So the so imagine what kind of power servers would have, data centers would have, if there's something that fits, if something so powerful that can fit your hand. Imagine what something bigger in size could do. So the technology today is far more advanced. We have 5G coming up, right, which is being experimented and rolled out. We have, fiber optics, so connection is of no issue. So cloud computing is there at your fingertips, and you have servers available online that can do your work. So technology has advanced. So when technology has advanced, what happened is that tools became available. The huge amounts of data that we were storing, you have more space to store that data, and when you have more space to store in data, you can use the huge history. You can use different types of data sets, and then you have also tools available now. The calculations that were happening in the mind or on paper moved to machines. Those machines became more powerful, and then the tools became more user friendly. So things that required huge lines of code now are being done with a few lines of code. Let's say hundreds of lines of algorithms now got compressed into a single line of code by using a library on Python. So there were advancements in different aspects, in technology, in systems, in tools, in knowledge, which led to this expansion of this field and more acceptance of this field of different types of resources, rather than just having mathematicians, statisticians, technologists in this area. Now you can have marketing analysts, business analysts, doctors, engineers, geologists in this area, right? So if anyone can enter this field, what's the cornerstone? What's the key behind it? What do you need to have to enter this field? Do you need to have a degree? No. Do you have, do you need to have uh, advanced coding skills? I don't think so. What's necessary to get inside this field of data science is an analytical aptitude, which basically is a logical mindset. That if you can view a problem rationally, if you can break it down into parts, if you can make a logical framework that if I do this, this will happen, or if this happens, then the prediction is this. If you can break a problem in these parts, then probably you have a logical mindset. At times we do see people who get carried away with blanket statements that this doesn't happen in Karachi. That they give generalized answers, like in defense, you won't see sales of, let's say, uh, you know, uh, small sized bread, let's say. So we see business people, or we see people making these blanket statements. But then as an analyst, if you can think, why is this happening? Is this just a false fact, or can this be verified through data? Can I drill down through sales data and see why is this problem happening? So if you have that DNA of an analyst, of breaking the problem down, studying it through details and data, then you have that analytics aptitude, and then you're ready for this field. So you can go through these, how the technologies were advanced. You won't be tested on this. If you raised your hand, you can, contribute.
So business knowledge भी is a main part of the data scientist. Business knowledge होना चाहिए इसको. I Hello.
Exactly. बिल्कुल सही. Because analysis on its own does not stand. You need to have context. So that context, yes. So that context comes through your business knowledge. So, and I won't say business knowledge, you can say subject knowledge, right? Because through business, we usually restrict ourselves to, people who are selling and marketing and finance, and, but context knowledge is, it can be medicine, it can be human emotion, it can be, even matchmaking for people, when people are looking for their life partners. So that matchmaking, can it be done through data science? I guess, yeah. If you can ask people to fill in forms, get their knowledge, the type of people they are, their hobbies, their interests, their educational background, the location they're living in, the income that they're earning, right? And, uh, uh, probably you can do that. You can do matchmaking through an algorithm that you can recommend life partners to people. So yeah, any problem that you can define through data, through algorithms, probably that's the problem you can address through data science. So yes, how did this? So this evolution of data science or analytics, uh, it's a stage-wise process through which I've seen companies go through. Our clients usually go through this phase that initially you collect a lot of data, you have tables and tables of data, but then you start wondering what I can do with it. So you start off by establishing reports and dashboards about that data. So you start describing uh, uh, your business through that data. So how much am I selling? How much am I growing? Uh, which products are selling, which products are not selling, which salesman is performing, which salesman is not performing, which branches are profitable, which branches are not profitable, right? And which warehouses are efficient, which warehouses are not efficient, uh, which hospitals are well managed, which hospitals are over-resourced, that they have hired too many people, right? Which educational institutes are uh, high ranking. So, when you get these rankings by HEC, they are based on a certain scorecard. So you get scores, and based on scores, you get ranked. So you are describing basically using that data, right? Whatever has happened before, based on what your past performance is, you just describe it, that how things are going. Then the next level becomes you've described your entire business, you've charted out all your vital statistics through data. Now what's left? Probably nothing. You've nothing left to describe. Then the business starts wondering, what can I do more with data? How about diagnosis? If I have a certain problem, let's say this area, let's say the area in defense is not giving me much business, right? You start diagnosing why. Is this area relevant for me? If that's yes, okay, then why am I not getting business? Uh, or do I have enough outlets here? Probably not, right? Probably I'm not touching the right amount of stores to place my product. What's the visibility of my product in, let's say, my product sells in general stores. I have, uh, let's say, a packet of chips that I'm offering. Uh, are they available in all the stores? What's the visibility, right? And am I paying the right kind of incentives to the salesman? Do I have enough sales resource to cover that area, right? So you're asking a lot of whys from your data. So you're diagnosing the problem. Where is the root cause, right? So that's diagnostic. It's closely related to what has happened usually, because when you uh, describe what has happened, a lot of whys also come along the way. Uh, if your business is not growing, let's say your business in Karachi is not growing, you would say, why is it not growing? Then you'll say, yeah, probably all the areas are growing except defense. And then you say, why is defense not growing? And then you drill down and see that, yes, I'm not paying enough incentives, or I don't have enough salesmen to cover all the customers in defense, right? So you're drilling down, you're asking a series of whys and getting to the root cause. That's what diagnostic analytics is all about. When you've done that, okay, you found out a method of diagnosing through data, then you start wondering, what more can I do with data? Now my approach is usually reactive with data. If something bad happens, then I respond. A problem happens, then only I respond through diagnostic, and then taking corrective action. But can I predict an approaching train, right? Can I predict an approaching problem? Probably yes. Then statistical models come into play, right? You use probability and stats and use algorithms to predict what's going to happen in the future. If you have seasonal product such as ice cream, now in which season does it sell better? In which months does it sell better? Do I need weather to plug in? I have weather data available online, public data available online. I can download it from the Mausamiyat website. We have downloaded it in at Love for Data. It's publicly available. If you can download it and connect it with our sales and find out how rainfall impacts our uh, product sales, or how temperature affects our product sales, right? Then we can predict that if the weather tomorrow is going to be hot, then my sales are going to be better. Or if the weather in the next month is going to be cold, and if I am selling ice cream, then probably my sales are going to be lower than this month. Then comes, you can predict, how it's going to happen. But then uh, if you can predict beforehand to take corrective actions, right, which is prescriptive analytics, what can you do to get a desirable action? What do you need to do to increase your sales in the future? So that's prescriptive analytics. And then you get to cognitive, where you have systems which you can interact with, which are working on their own, which are AI based, right? So you can see that there are websites which have chatbots available, where you talk in a chat box and there's no person behind it. So usually companies have figured out what kind of questions people come in with, and they have understood the path of knowledge that people take. So in that chat bot, when you write the question, you get relevant answers, and probably you get your queries get satisfied quicker, because there's already a prediction of what kind of questions you're going to take from your first question, or even from your profile, that they can help you out to get quickly to your solution. So these are different stages, and you keep wondering, what more can I do with data? What more can I do with data? And you keep advancing through these stages. Anyone who have a question until now? We can take a break, 10-minute break if you want.
Excuse me?
Yeah.
Can we see the back slide for half a minute?
Yeah.
I missed the slide 13 and 14. Can you repeat that, please? Because of connection problem.
You can refer to these as we'll be sharing them. So you don't have to worry about noting them down or taking screenshots or whatever. You'll get these slides when we close the session today.
Okay.
So it's 9:02. We can take a 5-minute break. Let's take a 5-minute break and then we'll gather back. Okay. Thank you. So let's start. Okay, let's move on. So what data science, we've defined data science, right, in detail. It's getting insights from data. Why data science? So part of it we've covered, that previously we had challenges, right? That we didn't have the right level of storage, right? And data was not being tracked. The stream of data was probably very fragmented. आप खुद देखें, if you have data stored in papers, even currently there are institutions like, government institutions where data usually is residing in a lot of paperwork. So those will be digitized soon, right? Like with time and with the right technology, people usually, कहते हैं government and legal institutions, they take time to catch up with technology, right? But as when they catch up, right, you will also see them also digitizing um, their data that they have. Cases which are happening in courts can be digitized. Government can digitize the different data that they are collecting. Let's say census data, immunization program data, right? Data about rural health, data about government schools, data about colleges, data about central data repository for credit, right? Um, Data related to crime, police, data related to city management, where you have data, let's say you've geocoded the signals in different roads, right? Manholes, right? What kind of facilities are available in a certain area, right? So imagine, with as your data matures, you can put more usage into it. You can get more value out of it, right? So as we've matured in recording that data, we get, let's say, previously when you would visit general stores or supermarkets, you would still get, your invoice on pen and paper, right? Through pen and paper. But now when you visit these supermarkets like Imtiaz, Motaz, Amy's, or Nahid's, you'll see that they have POS installed. So whatever you are buying is getting recorded. If you've bought their loyalty card, probably they also know details about you. If they have made you fill a form about where you live, about, or if they've made you install an app, right? Let's say you've installed Imtiaz app, right? Or if you've also connected on their Wi-Fi when you have visited Imtiaz, then they know more about you, right? So they can create a customer profile on that and can give you suggestions on different kinds of promotions. They can give you suggestions on the kind of products you buy, right? If they have an e-commerce platform like Daraz, or even Nahid has an online e-commerce platform, they can ask you to make an account where you fill in your email address, your contact number, and they can ask you questions about where you live, or uh, the kind of person you are, whether you're a male or a female, whether you are living in which area are you living, or so they can ask you multiple questions and you can fill in. right? At different customer touch points. Even when you're visiting Nahid, they can fill in forms. So the more they know about you, the more customized they can do their marketing to get more sales out of you. It's bringing in, so it's a win-win, right? It seems like you're being manipulated, but there's a positive way of looking at that. You're helping them understand your needs better, and they're getting more business value out of it, and you're getting more relevant marketing out of it, right? Then data has also the storage space. So I remember my first PC, right, had 1 GB of hard disk, right, and that's it actually it had 512 MB of hard disk, and then I had gotten it upgraded to 1 GB, and the RAM that I had was about 64 MB. So imagine how technology has advanced even through my lifetime, right? And yesterday, what you can fit in a room can now fit in on a small chip that can be placed on your fingertip, right? So technology has advanced due to which you can store more data. So storing data now is not a problem. It's only access to that data, right? So, and then with this exponential increase in technology, there is an increasing need of talent, of skills that can use this technology and data to create business value. And hence that answers the question of why data science. Data science is there because now you have exponential growth in data coming in, which needs to be uh, channeled to create business value. So we need thinkers, we need problem drafters and solvers, right, in this field. So there are few areas, and we'll just chart them out in data science, right? Um, these are just, you can also say, you can connect the slide to the buzzwords. There's some more buzzwords or some more terms that we have that get used in this field. Data architecture, uh, this is the area where you are modeling, right? We are working with data. You are understanding the raw data in the form it's stored, and so most of the time when we go ahead, and even during the certification, most of the time you will get data in just one table, right? This, which is just basically a single sheet which to you use do some cleaning on it, engineer some features, and then feed it into a model. But in real life, that doesn't happen, right? You get data in a fragmented form. Now, when you approach a client, when LFD approaches a client, they say, we want to do sales forecasting. They don't know which data to use, right? That's up to us to tell them and work with them to find out which data sets they have, where do they reside, pull them out and consolidate them in one place and make one consolidated data model out of it, which can then be used inside a prediction model, right? So yeah, you need to have idea about data architecture. So you go to a client, the client would say that, yeah, I have sales data in SQL database, and you can use SQL query to access that data and make a model. And then I have promotions data, which I record manually in Excel sheets. Now you need to connect that with the data that you've got for sales. I have inventory data, which is in my warehousing solution, which uses a different kind of database technology, right? Uh, let's say it's another database in SQL, right? So yeah, you are understanding their data, you're making linkages out of it, you're making a data model out of it. So that's understanding their data architecture. So that's what it's all about, charting out the different data that they have and its relationships. That's all about data architecture. Then comes statistics and applied mathematics. Both uh, are used in prediction. You're using stats and hypothesis testing to understand which features are important, which So features are basically, input columns. So when we talk about sales forecasting, you can say that weather or temperature is one feature, rainfall is another feature, um, time of the day can be another feature, which can define sales, right? And area can be another feature. Um, and nearness of an outlet to a school can be another feature, distance from a school. So wherever an outlet is near to a school, its sales are probably going to be higher, right? So um, these are basically features, right? Input columns, which you can study through stats and applied maths and find out which of them are important, which of them are not, and how important are they, right? Using stats, you can identify how significant they are in defining your target variable, which is your sales, right? So I talked about two key terms here, feature and target. Feature is all the input columns that you have, and target is your prediction that you want to make. So when you talk about sales forecasting, sales is your target, and every other column basically is your feature. When you talk about loan prediction, let's say you want to predict if a person is going to default or pay, the target variable is the payment behavior, which has two values in it, default or pay, and every other column, such as the income level, location, whether he's in a rented apartment or an owned apartment, how many dependents does he have. Those are all features or input variables, right? So you use the stats and applied maths to find out which features are important and to make predictions, right? Every algorithm has its own theory, has its own uh, mathematical design. Now, question comes up: how much detailed do you want to have, knowledge for in this area? Um, of course, the more knowledge, the better. But there's a good saying to satisfy that question, that a, a data scientist is supposed to have better programming skills than a statistician, right? And better statistical knowledge than a programmer, right? So he's kind of a hybrid between the two. He doesn't have to target knowledge that a regular statistician has, and he doesn't have to target the coding expertise that a regular programmer has, right? He has to be midway. But of course, more of something is always good, right? You can, and this field, frustrating though it is, but this field is something which requires continuous learning, right? People who have done PhDs are still reading articles and gathering new knowledge about how this field is advancing. So it's nothing like sales or finance. Probably even in finance, you have to keep update your qualifications, right? But this field more so requires continuous perusal of different articles, of different online courses you can take certifications just to keep advancing, to advance your knowledge, right? So it's a continuous learning um, field. Visualizations and business acumen, yes. Describing a problem through data, doing impactful visualizations and reports to describe a problem, that's a good area in this field. And then you have spreadsheets, which basically, you put things in a table, in Excel sheets, put filters on it, and study it. So yeah, spreadsheet is a regular Excel sheet that you have. So this exercise, this can be an assignment, right? You have to write down. So as you've gone through this process of gaining knowledge in this first session, uh, I hope it has created a mushroom cloud of ideas in your mind, uh, of different kinds of examples around you in your job, at your home, and you can pen them down, right? Uh, Write down examples. Just one, write down an example related to data science from your previous knowledge. define it in its level of detail and try to figure out how things are happening inside that example, right? So, uh, or write three examples, right? Because I guess one would be too short. Um, write three examples of data science uh, in your business area or at your home, and try to figure out how it's working, just in general ways. So why is data science needed now? So get instant insights, right? Better analytics. You can improve business performance through on-time analytics. You have vast amount of data available. You can get better insights from structured, unstructured data, and it helps decision making. So it's an enabler. So at times it's taken as a threat as well. We get questions like, is AI going to replace people, right? Uh, so you can say companies which have a team of analysts, would this technology take out the need of those analysts? People who would run ad hoc reports, ad hoc analysis, would they go away if you have a data science solution at hand? I would say now that's not the case. AI and data science are enablers, but not a threat. They help you get to a decision faster, right? And more so, since these systems are coming up, it's very important for people to focus on the right kinds of skill sets. So we've got lifts, right? Lifts used to have lift operators, right? Now you don't have them, right? Because now they're not that complex to operate, and probably people are not that, they don't require that much of service, right? That pushing, you need to have a guy pushing buttons in a lift, right? So they're out of business. So anyone who tries to target that profession is probably uh, going for a disaster. So it's all about what you want to target. So if a person is complacent about extracting reports and just summarizing them without using much uh, thinking behind it, then that person is probably going to run out of business. But if you are an analyst who adds value to that data by interpreting that data and getting the right insights out of it, then probably you're going to stay wherever you are. Nobody's going to take away your job, right? So what kind of jobs can be targeted that will be there? We'll get to that as we move uh, through this certification. So this certification should also be taken as a process of self-discovery, because there are different areas in this field. It's a team job, not a not one person's job. So you can focus on which kind of roles attract you more, right? Which we'll come to in this session. Evolution of data. Now, yes, we've grown in data and its access. So companies used to have access to internal data only. Now they have web, they have data coming in, which is publicly shared, data which can be taken out from social media, right? So you have different platforms where data is available and you can use it for your own business decisions. So data has grown in size, in variety, in complexity, and that's why you need this skill set to be there. Just a few examples of how data has grown. You can imagine, Walmart, and you can take local examples. You can try to assess how much data do they generate on a daily basis. So, each customer, if they're buying, let's say 10 products, not even 10 products, on average, if they're buying 20 products, right? And there are thousands of customers visiting a single outlet. Let's say a single outlet gets visited by 1,000 people, you say 20,000 lines get generated by a single outlet. And if you have 10 outlets, the scale reaches to 200,000. And that's a very conservative estimate, because you can have all the different types of data sets, about inventory as well, about HR staff as well. So imagine the different types of data that a simple store like Imtiaz is generating. So then moving on to something which is digital, services like Facebook. Imagine the number of posts, the number of shares, the number of likes that are happening uh, the world, globally, right? So it's beyond our imagination. We can't even put a number to it, right? Uh, you have banking transactions happening. We have clients in finance and banking, and uh, the initial challenge that we get, so banking and telecom, right? They have a huge customer base, right, which runs in millions. And then each customer is performing hundreds of transactions per month. So you can imagine the size of data. So once we studied 3 months of data for a telecom client, and the data that we received related to call logs and related to the subscriptions that a person did, right? The amount of data that we got was more than 50 GB. And to process that data was a challenge. So using the right kind of technologies to process the data, summarize it, make a model, get predictions out of it, right? That was a challenge. You have, telescopes taking data of images, right? You have CCTV data taking, which are installed at different places in a city, and it's taking data from different areas, right? So imagine the number of pictures and the length of videos that are coming in through CCTV footage, right? How can you use that? How can you process it to help aid in crime prevention, right? Then you have uh, data coming in from research in human genome, right? And even you can say, the research happening in the battle against COVID, or the number of scans that come from a single hospital, right? The number of scans, the X-rays, or results from different machines, monitoring health of a person if he's in an ICU, his heartbeat, blood pressure. So imagine the data that is flowing in from hospitals. You can use that, to your advantage. So in summary, you have data all around you. All you need to do is just chart it out and use it in some model to create business value, or to help people do the right decisions. So we've covered up pretty much the different areas. Sales and distribution, I won't touch upon, already done, right? Healthcare, you can use for diagnosis, right? Predicting if a person has chances of developing a cancer, so that it's always good, right? Preventive cure is always better than uh, curative, right? Uh, the cure which, when it's already happened, right? So uh, healthcare can help improve the overall health of people. Then in banking and finance, we've already covered loan prediction. We can also look at suspicious accounts, find out where the network of people where money is flowing through illicit means, right? The network of accounts where a person is using, which a person is using to transfer illicit funds from one place to another. Using consumer market analysis in retail to identify what kind of products a customer buys when he visits an outlet, and recommending him. So, when you go to an e-commerce platform, let's say Gul Ahmed's website, you buy certain products, you get recommendations at the bottom. those recommendations are coming in from machine learning engines, right? Then e-commerce, yes, we've already covered that. And then telecom. So yeah, one of the main requests that we get is churn prediction. That is, you have a, let's say Telenor has a customer, and the Telenor wants to know what are the chances of this customer leaving me in the coming 3 months, right? If the chances are high, Telenor can approach that customer via a marketing message that please subscribe to this package. You are eligible for that, and you'll get certain GB of internet free, and you'll get this call package. And Telenor can use marketing strategies to avoid that churn, right? So how can a churn be predicted? You can say that a person who has stopped recharging his phone, right? A person who has unsubscribed from uh, some of the packages, right? A person who has suddenly dropped usage of his Telenor SIM, right? So when you talk about such features, you start realizing that these models are not mystery models. They're pretty much scientific. They're using some common sense, some sensible technique to get to a decision, to get to a reasonable level of idea that this person is going to churn, this person is going to default, this person is going to buy this much, right? This person can probably is going to develop diabetes, right? So it's all about figuring out through data and statistics that what are the chances of this person doing something. Customer service, target marketing, segmenting customers. You talk to a young customer in a different way, you talk to an innovator in a different way, and a follower in a different way. So if you have segmented your customers, you can design your marketing messages based on that. HR analytics is a great field as well, where whenever you're applying to any company, you fill in a huge amount of form. That's a wealth of data which you can use to do matchmaking related to a role. So even before your CV gets to an interview level, it already has passed through an algorithm to see if you're fit for that role or not. So that can help. And then with the current employee base that a company has, you can use their data to see how they're performing, or what are their interests, where can they go in their next role. So there can be recommendation systems based on that, right? Or if a person is going to churn from the company or not, if he's going to resign or not, if there are high chances of that, and if that person is key, you can approach him and find out ways where you can incentivize him and make him stay. Now we come to the data science lifecycle, going through all these use cases. Until now, do you have any questions, right? Let's have a few questions if there are any, and then we can move on to the data science lifecycle. Best way is raise your hand and use voice to contribute a question. Typing in a chat box makes it a little more difficult for me to. So there was a question by Zahida Naz. What is the difference between AI, ML, and data science? As AI and ML engineers should have coding skills, but you mentioned that for becoming data scientists, we don't require coding skills. So coding skills are needed to a certain extent. I'm not saying that you have to do away with coding skills. Even in this course and the coming courses, we will be doing a little bit of coding, right? But the trend is that there are solutions like NIME and RapidMiner, which are doing machine learning, but then they require less code. There's more trend towards having UI based tools, right? Where you do click and use different buttons, and you still have to code, right? But then the trend is that you're getting tools now which have UI in it, which means that coding is becoming more and more simplified. This is a skill which, though it would help, but more important to that is the skill of understanding a problem and applying machine learning knowledge to it, right? Going back to the question is the difference between AI, ML, and data science. So data science is the umbrella field of analytics, which includes machine learning. We've defined machine learning, which is, improving a performance or a task through data, right, of a system, right? That's machine learning. Data science is more generic, that it includes machine learning as a subset. It includes BI as a subset, right? Business intelligence, right? And it's all about using data to get value, to get insights. So when you're doing machine learning, you're doing prediction of sales forecasting. You're using sales data to get predictions, which is creating business value, which is reducing your forecasting error, which is improving your inventory management, which is reducing your sales loss due to out of stock situations, right? So that's creating business value. So yes, machine learning is part of data science. AI comes into play when you have more advanced models in place which make systems behave on their own, right? Which is artificial intelligence. It includes robotics. It includes self-driving cars. So it includes chatbots, which are uh, which for which you need less control. AI systems are systems which need less control, which are less unidimensional, because machine learning is probably just, you input data and you get a prediction out of it, right? So that's machine learning. But AI is more advanced, like games have AI in it, right? Enemies, or, uh, they are non-playable characters as well. They have AI as well. There are certain games, right, which have characters that are following their own life cycle, right? They go, they have food, they cook food, and they go to a job. So in GTA 5, if you see that people are, going through their own life cycle, so that's AI, right? They're behaving like actual people. In self-driving cars, the driver takes a back seat and the computer takes into account the different data coming in from sensors, and it's adjusting based on the situation that it's in. So if a speed bump is approaching, it'll slow down. If there's another car, probably it'll brake, right, and adjust its direction. So, and even in chess, so there is an algorithm, AlphaGo, which actually made a historical landmark of beating a chess champion. How did it beat? It took the data from all the previous games and learned from that, and it played with the chess champion. I think the first one, you can read upon it. The first game it lost, the second game it won, or probably it was the third game that it won. So it learned from its mistakes and uh, started winning. So AI based solutions are probably a bit more independent than machine learning. Machine learning is using data to get some output, right? That output is probably very simple, such as loan prediction is whether he's going to pay back a loan or not, or a credit score, or a sales forecast. Pretty much a bit simple, right? AI has a bit more advanced uh, concepts related to it. Any other question? What about the point of information safety when filling forms? So Talal had asked this question. If you can elaborate a bit on this question, probably I'll be able to answer.
I think when you talked about mm, the different uh, amalgamating and big data things that when you fill out the forms,
like loyalty cards and all that. So what about the aspect of data security when we actually give out our information to different platforms, or maybe to different stores like Ideas or Gul Ahmed or XYZ, anything for that matter? What about the data security? That our data will not be leaked to unscrupulous or any hacker or individuals that may use it for illegal purposes. So what about that?
So that's a separate field, of course. Any company which has data has its has takes measures to protect it, right? So data can be encrypted, data can be put behind secured servers which are difficult to access, right? So that is a separate field. You can have barriers to hacking and stuff. So that's something which you can study when, if you want. There is a separate uh, you can
So
search for, but
isn't
more
there
so.
this other thing called blockchain where you can like not actually reveal your data to others, but you can still do transactions, microtransactions, and you will be still be verified that you have done that transaction, and others can verify that for you by the how do you call that, the address that you have put, like once you buy Bitcoin or something like that.
Let's
So
see. So um, they are fields by themselves, right? So at this point, I can't tie in any concept with data science, right? But what brings to my mind, what you've talked about, data security and stuff, what brings to my mind is ethics in data science, right? So
yes.
one thing which is very important is that um, when you design an algorithm, right,
Mm-hmm.
it's the responsibility uh, of the developer is to make that algorithm ethical as well. Now, what do you mean by that? The What do I mean by that? That is that, there are certain elements in your data which may create bias. Now, let's say you have gender. Now, do you want your algorithm to be gender biased? Now, if you don't tell a machine, it might create a bias. Let's say you had customers which, out of which the men were defaulting more than women. Now, a system is indifferent, right? It's insensitive to these nuances that we have, that you should not be gender biased. But then an algorithm will be trained on data, and it will create biases based on data as well. So there is an entire field on ethics in data science, which we can read upon and understand, and must. So what happens is technology, and we've seen it with the cases done on Facebook. Technology advances at a faster rate than the legislation and the law, because
Right.
these are new scenarios being created, where you don't we you never have any precedent for such scenarios. So law has to understand those
Okay.
scenarios and come back with legislations that can control, that can help data science make its practice more ethical. Is so how's the data being shared? The privacy of an individual. If you're registering on Facebook, making an account on Facebook and storing your data there, should that data be shared with someone else? And should it pass boundaries? Data of a person in Pakistan, should it be shared with someone in USA, right? So these are concerns that we have in data science, right? And while developing a model, at times, so usually when the techies, they focus on the coding and the getting an accuracy out of the model, but then they forget about ethics, and at times it kills you. You know, when if you've developed a model and it's good, it's working fine, and at the end someone asks, you know, is this ethical or not, and you come up with uh, you know, that some of the features are not ethical, and you then have to go back to the drawing board. So it's good to factor in the ethics in building data science models at the start.
Right. So one thing that came to mind when you talked about ethics is neural networks and all that. You said that it acts as a human mind and programs the machine that is basically using that algorithm, that predictive framework is powering that. So isn't uh, i- is the bias going to be, I don't know where I'm going with this, but guide me if I'm wrong. Wouldn't the neural network, factor in the ethics for it? Because it's trained to work like the human mind. So what comes to mind is that shouldn't it also, grab upon that, scratch the surface of that,
So
of
so
the ethics that we kind of feel,
So I get your question.
since it,
I do get your question. The thing is that it's objective, right? The neural network, it's not subjective, it's objective. It takes data and it makes signals out of it. Now those signals can be biased. So, you know, take that as a human which relies fully on rational thought. And you can see that in that thought process, you will have some fallacies because that person is not sensing uh, you know, the environment around him. Now, ethics is a little bit sensitive as well. That you know, even though gender is a sensitive topic, or race is a sensitive topic, it might not be processed by human brain. It's only sensed by probably the heart. So
right,
uh, that's why you need a person in this field. That's why we can say with a good level of confidence that AI will not replace humans. You need people to govern that
right.
technology
So
to help decision making.
right. So the coming back to your point of like, that lifts, you don't need operators to like push buttons and all that, but you do need an operator with a mind that understands the AI better in the right context, so that it doesn't go astray, so to speak.
Yeah, yeah,
All right,
that's true.
thank you.
Well, so getting back to data science life cycle. So the fundamental phase that we start the life cycle with is business or context understanding. Why are you doing this analysis? Why data science? Or what problem are you trying to address? Right? And this is done by sitting with your client, or you know, if you are the client and you are doing the development, then yeah, you have to understand your business and see you have this data, and or not even data, you know, you're just saying that my problem is that I'm not able to sell to my customers because I don't have products available, right? I'm not, so either at times I produce too much and I end up wasting my inventory, or I incur a lot of warehousing costs, or at times I produce too low that when a customer comes to an outlet to purchase my product, it's not available. And when it's not available, the customer has that need, right? He wants an ice cream, let's say. And if my brand is not available, what's next he's going to do? He's not going to not have ice cream. He'll definitely will have ice cream, but he's going to buy someone else's product, right? So I'm going to lose customers and sales, right? So either I'm producing too much or I'm producing too less, right? I need to have that optimum level to produce so that I don't end up wasting my inventory and I don't end up losing customers. So I need a proper demand forecasting or sales forecasting model, which has, let's say, now, yes, you can't have zero error, right? So you can say that I need to have an error of around 10%, right? Either I end up now, probably now you can even go on the specifics and say that I can afford an error of plus 10%, where I end up losing 10% of my inventory because of expiries, right? Because I produced too much. And I can afford an error of minus 5%, where I end up producing less and my customers don't get that product and buy something else, right? I can afford minus 5 and I can afford plus 10. If you go to the specifics of this, right, then your objective is clear that now I need to address this problem.
I have a
Now,
really good real life example for this. Uh, do you know the Japanese market for cars? There's Daihatsu and there's Toyota. So I've heard somewhere that both these brands, one of the brands is an umbrella brand of the other. Like Toyota is basically a top brand, and under that comes Daihatsu. So both of them have the same car with the same features, same specs, same everything. Just the matter of the badge is different. And that car is Mira. Mira and Pixis Epoch. They are basically the same car, and what they do is basically they go half and half. They produce, okay, so 500 cars of Epoch and 500 cars of the other one, the Mira. They produce these, and whichever does better, they test market basically, the A/B testing thing. So what they do is they go and like sell uh, Mira, and they go and sell the Epoch, and whichever does better, they just replace the logo, the Daihatsu thing. Sorry, not the Daihatsu thing. They replaced the Toyota badge with the Daihatsu badge, and they make it. They say that this is the Mira, and they have the because it's manufactured by the same thing. It's just a matter of consumer preferences that people prefer the Mira to the Pixis Epoch. So there. और यहाँ पर भी यही हो रहा है, मतलब जो इम्पोर्ट कर रहे हैं वो पिक्सेस ईपॉक आपको इक्का दुक्का नजर आएंगी, उसके अलावा जो है यहाँ पे भी जो है वो मीरा यूज हो रही है गाड़ी.
sure, sure. So how they are predicting?
I think they're like as I said, they're doing test marketing. That in some prefectures, some areas, वहाँ पर तो prefectures होते हैं ना कि कुछ areas के अंदर जो है वो test market करके देखते हैं यहाँ पे कितनी sales आती है और यहाँ पे कितनी sales आती है, तो वो उसको comparison करते हैं, कुछ analysis करते हैं उसका कि they just take the figures and see कि कौन सा जो है वो ज़्यादा अच्छा बेहतर perform कर रही है, और फिर उसके बाद जो है वो उसको turn कर देते हैं Pixis Epoch को मीरा के अंदर, and they just those cars sell like hotcakes. मतलब कम इंजन वाली कैटेगरी में they sell like hotcakes over there. और यहाँ पर
Sure.
भी जो इम्पोर्ट हो रही हैं वो उसी तरह जो है they do that.
Sure, sure. So of course, a lot of tones can be tied to this problem. There can be also sentiment analysis where which type of cultures or which types of communities prefer certain type of brands. So would a socioeconomically better community prefer Toyota than Daihatsu? That's a question that you can test, right? And so
exactly
this also brings me to a point of new products. Now we've worked on a new product which was not available in the country, right? So it was a nano loans product, and it was done in Egypt, and there was no other competitor, and there was no history of data. So the challenge was to assess how much volume are you going to get, right? And we didn't know about it, right? The but the rough we can only do rough estimates on that. In that case, when you have no data, what you have to do is you have to explore as you go. At times, you start off with a certain sample, right? You launch your product in a certain area and a certain community. You test it out. You understand that yes, out of 100 people, 30 people are liking my product. Then probably in this area, I can fairly assume that out of the census of 1 million people, I can get 30%, right? So that can give me a business volume. Then when you open up to new areas, new kinds of customers coming in. So um, even with Apple, right? When they were launching the iPhone for the first time, they wouldn't know what the response of customers is going to be, but they probably got a fair idea by doing this hypothesis testing and A/B testing to get to a certain level of feature set that define their product, right? So yes, that you do that to get more clarity on your context, tying it back to business understanding. But running experiments at times, okay, if your product is new, if your situation, your setting is new, you can run these tests to understand your problem better, right? Or at times you can, and we'll see that uh, as we further in this life cycle, you'll see that there's no uh, unidirectional path. You don't have to just keep going forward, that you don't close a process. So once you're done with business understanding and you move on to data, it doesn't mean that you won't visit business understanding back again. You can visit it back. If you've explored data and understood certain areas about your business, you can redefine your problem or enhance your problem statement by going back to business understanding. We'll get to that once we uh, discuss it. So it's already 10 o'clock. We are done with the session. We have covered a good amount today. Uh, I guess this is also a heavy amount of knowledge as the first session. We can close it now, and we'll touch upon the remaining phases of the data science life cycle. And in tomorrow, we'll finish it off and do some more theoretical work of session 2 slides. And then in the next week, we'll do we'll start with hands-on, right? You don't have to do the assignment right now. So the process would be that whatever assignments get assigned during the 2 sessions, those will be due next week on Saturday, right? So you can submit those assignments by end of Saturday next week. That will be the regular flow. Any assignments that I assign like on Saturday won't be expected next day. You'll have for each assignment at least a week or 6 days, you can say, to finish it off, right? So any questions until now?
No, sir.
Fine. So I guess we're done. Thanks a lot
Hello,
for,
sir.
yeah, please. Go ahead. Yeah.
Assignments will be shared in group.
Yes, they will be shared on WhatsApp. They'll be shared. So I'll get back to you with that after discussing with Konain. Previously, we had Yamna who would regularly share assignments on WhatsApp, but I'll just get clarity. We'll communicate over WhatsApp and let you know how they'll be done.
Okay. Thank you, sir.
Okay. So all well. Have a nice day or night ahead. Inshallah, we'll regroup tomorrow, same time, 7 o'clock, and continue with this. Okay.
Okay, thank you, sir.
It was a pleasure, sir.
Allah
Thank
Hafiz.
you.
Allah
Allah
Hafiz.
Hafiz. Allah Hafiz. Take care.